Welcome to Tropics 101, a course by myself, weather follower, to hopefully teach you the ins and outs of what it means to be a tropical forecaster. In our first lesson, we learned how the MJO provides the upward motion needed for a tropical system to breathe. However, lift alone is not enough to create a monster. To understand why some tropical disturbances explode into major cyclones while others remain weak disturbances or depressions, we must look beneath the surface. Today, we are exploring ocean heat content, OHC, the true measure of a storm's fuel supply. Be sure to like and subscribe so you never miss another one of these. The playlist for each module will be linked in the description. Most people rely on sea surface temperature or SST maps, which only show the temperature of the very top layer of water. You have likely heard that 26.5 degrees Celsius is the magic number for a storm to survive, but SST can be deceptive. A tropical cyclone is a violent engine that churns the ocean. If the warm water is only a few meters deep, the storm's own winds will bring cold water to the surface, effectively self-chilling the system. OHC tells us how deep that warm reservoir actually goes, ensuring the storm has a continuous supply of energy. Forecasters measure this fuel by looking at the 26 degrees Celsius isotherm depth, the depth at which the water temperature finally drops below the threshold for tropical development. We calculate the total thermal energy available from the surface down to this depth, measured in kilojoules per square centimeter. Think of it like a car. SST tells you if there is petrol at the nozzle, but OHC tells you how many gallons are actually in the tank. When you look at an OHC map, you are searching for specific danger zones that trigger rapid intensification. Values under 40 kilojoules per square centimeter are generally considered neutral, where a storm can survive but likely won't strengthen quickly. However, once a system moves over water with 75 to 90 plus kilojoule per square centimeter, you're in the high-octane zone. These deep pools of warmth, often found in the Caribbean, the Gulf Stream, or the warm pool of the Pacific, allow a storm to jump multiple categories in strength in under 24 hours. To master long-range tropical forecasting, you must overlap these maps. First, use your MJO phase diagram to find the window for when the atmosphere will be active. Then, look at the OHC maps to see where that activity will have the energy to explode. When an active MJO pulse aligns with a high OHC reservoir, the conditions are primed for a major cyclone. Understanding the ocean's depth is what separates a basic weather enthusiast from a professional tropical analyst. In our next module, we will explore vertical wind shear, the gatekeeper that can tear a storm apart, no matter how much fuel is in the tank. Thanks for watching, we will see you next time.